This is our counter module, which takes as input the clock and up button. And the initial problem we were having with this counter was that whenever we pressed the button, the count would increase by a random number. And so to fix this, we had to create a debouncer module, which takes in the button input and synchronizes it to the clock and debounces that signal so that whenever we press the button, we only register one instance of that button press. And so we take that count and input it to top, which also takes as input clock, reset button, and result of the operation that we entered. And so for the VGA display, we want 25 megahertz, and the clock is 100 megahertz, so we have to divide that by 4 to get 25 megahertz. And we then make wires for X and Y, which are the positions of every pixel. And then we call this VGA display module, which basically sets up all the timings needed for the VGA and sets up the screen. And so then we make 5 wires for X and Y positions, and we did this to make boxes. And we use the boxes to make a smiley face. So this part of the code checks to see if counter, which is the current count, is equal to the result of the operation that we entered. And if they are equal, then it sets these 5 squares that we made equal to the green output of the VGA, which would make a green smiley face. And if count is not equal to result, then these squares are assigned to the red output of the VGA, which makes a red smiley face to show that the answer is incorrect.
Here we have our modified ALU. We edited one of the logical expressions. Before it was just not A, and we changed to not A and B. And this operation was just not B, and we changed it to be not B and A. This arithmetic expression before was just negate A, and we decided to do an algebraic expression, so we did 3A plus B. To do this, we added A 3 times and added B. At first, we tried to multiply 3 by A, but that was giving us different problems. We decided to just add A 3 times. And we did the same thing for the next one, which was before negate B. We added B 3 times and added it to A. Then we have what used to be A plus 1. We did A plus B plus 1. And lastly, we used to be A minus 1. Now we have A minus B minus 1.
We're going to do not A and B, and the code for that is 0, 0, 1, 0. And then we are going to do for A 1, 0, 1, 0. And for B 0, 1, 1, 1. And that should yield 5. So when it gets to 5, it should turn green. And then when I go to 6 and every other number, it goes back to red. Next, we're going to do not B and A. So we're going to change the code to 0, 0, 1, 1. We're going to leave A the same, but we're going to change B to 4. So that's 0, 1, 0, 0. And that should yield 10. And it turns green. Next, we're going to do 3B plus A, and the code for that is 0, 0, 0, 1. A is going to be 5, so 0, 1, 0, 1. and B is going to be 0, 0, 1, 0, so 2. And that should yield 11. Next, we're going to do A minus B minus 1. The code for that is 0, 1, 1, 1. We're going to leave B the same, but we're going to change A to 1, 0, 1, 0. So that is 10 minus 2 minus 1, which should yield 7. So 1, 2, 3, 4, 5, 6, 7. Turn screen and back to red. And that's our design.